Hello! So this video is intended to help students that are learning how to write linear equations in two different scenarios. One is where they are given 2 points, and another, here I'll switch to the next one here, is where you're given the slope and a point of that linear equation. I'm going to be using a couple of them, a couple of different things you'll need for this. One is going to be this, what's called the slope-intercept form. And as these questions are requiring me to use both x and y, that's what I'm going to use. But know that you can use any variables you like there, as long as you know what your inputs and your outputs are, then you'll be fine, right? You can identify any independent variable and any dependent variable and make it work. So with this first one, we are going to try to find a linear equation that goes through the points -5, -5, and then 5, -2. So I'm going to go ahead and write that down before I forget it. So we want it to go through that point as well as 5, -2 there. So that gives us a sense of what this thing looks like. You can almost, with your mind, try to connect those dots together so you can envision what those 2 points, or what that linear equation would be between those 2 points. Now these are the 3 things that you'll need to know here. Here is our slope-intercept form, which I brought up again. M represents the slope of the line, and B represents the vertical intercept, or in this case, since our dependent variable is y, B represents the y-intercept there. So it's going to be where it crosses our vertical axis, if you would. This next one are 2 given points. So for example, we were given -5, -5. We could call that, say, our x1, y1, and then 5, -2. That will represent our x2, y2 there. The reason why we need to know that is our definition of slope is going to come from this, this little hint for us, which is the change in y, which is how far we rise, over the change horizontally, which is how far we run over, which is going to be the difference in y, so between our y1 and our y2, and then the difference in x between our x1 and our x2 here. So it's important to know that as we move along. You can almost picture, say, these 2 points. We want to figure out, well, how far are we moving, say, up or down? So if we start at this left point, we can see we're going to move up so many points, and then we're going to move over, right? So in this case, we're going to move in the positive direction in order to get there. So again, if we were to use our definition of slope here, so I'm just going to take that and paste it right in here, and then we're going to call our x2, y2 this 5, -2, which means that -2 would have to go here, and then our 5 would need to go there. You notice that this is going to vertically stack our coordinate, which is what I like to do because it helps me check to make sure that I've got everything where it needs to go. So I would place my x2 or my y1 in is -5, and now I'm going to put in this x1 right here, which is going to be another -5. This will immediately calculate it. I'm going to refrain from looking at that and then instead show how to deal with this. The things that could come up here is you could get what's called a double negative there. So we have a minus and negative number. So the way I picture it is whenever you have 2 negatives like this, you will combine them to make a positive. So it'll turn that into -2 plus 5, or in this case, it'll turn into 5 plus 5 there. Again, it's calculating that for me, but I'm not going to pay attention to that. So on the top, we have -2 plus 5, which is 3, and on the bottom, we have 5 plus 5, which is 10. That's more important to me. So in my slope-intercept form, I can see that what I'm doing is I have to go up 3 units and then over 10. We can actually see that here. So from this point, -5 to -2, we have to move up 3 units, and then to go over, we are going to go over the 5, which will get us to the vertical axis, and then 5 more, so that would be 10 over. So that's how we get our slope. So it's important to know that this is one of those aspects of mathematics where you can have a visual for it, like you can have your points and then count them out, as well as you have this algebraic component, and there needs to be a good connection between these two as we move along. So in our slope-intercept form, we found our slope. What's left is to find our intercept, which is going to be, again, where it crosses the the vertical axis there. So we want to know, where is this thing going to hit? It looks like it's going to be between -4 and -2 to me, but the way we would find it is we would pick one of these points and we would plug them in. So I'm going to pick this second point here, just so that way we can see where the pieces go. And if we were to do that, then what that means is we would have to plug in 5 for x, and then down here we would have to plug in -2 in for y. And now we can see we can solve that. Okay, so I could have picked a -5, -5, but it's important to kind of see where those pieces are, because a common error would be to put them in incorrectly. So our first value here, x, would have to go here for the variable x, and then our second value here would have to go where y goes. So that's definitely something that we're going to have to pay attention to as we move along here. If we were to simplify this, we could see that we can cancel the 5 and the 10 and reduce the 10 down to 3 halves there. And then we can get rid of this 3 halves by subtracting 3 halves from both sides. It will cancel these 3 halves out, leaving us just b, which is what we want. And then this -2 minus this 1.5 would get us -3.5, or -7/2. So you can see that's going to give us that next point, which covers it. That point right there is -3.5. So if that was, say, right here at this point, minus -7/2, that gives us our equation that connects those 2 points together. Let's try it one more time with the next question here, where our points are now -2, 4, and then 1, -2. I had to write those down so that way I could come over here and start it again. So again, we're going to be using these 3 things, but now our points are going to be, covering up with my hand, sorry, -2, 4, and then our second point is going to be at 1, -2. So we're trying to catch those 2 pieces. And it's still the same thing. We're still using these. But if these are our coordinates now, let's say this is like my x2, y2, then I would replace this with a 1. Well, here, let me do it all the way from the beginning, so that way we don't have these pieces from the previous problem in there. If we were to plug in, say, 1 in for x2, and then -2 in for y2, we can see again it vertically stacks it. Our -2 would be what replaces this x1, and then y1 would be replaced with 4. So we again see that that thing is vertically stacked in there. And again, right, as we're going through, we can solve this thing. Even though Desmos is doing this for me, we can do it. So that -2 minus 4 gives me a -6. And then we've got a double negative here. So I'm going to put that negative up there. And then I'm going to deal with that. I should have done it first. So 1 plus 2 there. And then that 1 plus 2 is going to give me -6/3, which is just -2 as it was stating. So we know this part right here is going to be -2. And we're trying to figure out what b is. Well, again, here, I'm going to get rid of these things because they seem to be eating up the problem. We can find that vertical intercept. We can kind of see it, right? So if we were to go through, could we see like that -6? Well, sure, we can see that to get from this point, -2, 4, over here to 1, -2, we're going to go down 6 units, and then we're going to go over 2 plus 1, we're going to go over 3 units. We can see that this is maintained. And it's just that we can reduce that further. We can reduce this -6/3 by getting rid of those common multiples to -2. So yeah, we can see that piece of it. And we can kind of envision where about our y-intercept's going to be. It looks like it's going to be between 0 and 2. But we can pick either of these points. I'm going to go ahead and pick this second one here. And what we're going to do is we're going to replace this y with -2 and this x with 1. And this is what we're going to write out here. So if we move this along, -2 times 1 is going to be -2. And then to get rid of that -2, I'd add 2 to both sides, which means that we've got b equals -2 plus 2, which is 0 there. So if there was a 0 here, we could see that that would connect those those 2 points together, right? So it's this second number here, this 0 for the y-coordinate that matters from it. And another way we could write this, right, since it's negative 2x plus 0, is simply y equals negative 2x. That's totally fine. Okay? So we can see that that's how that's going to be used in there. So there's our first bit. Let's look at our second bit, where instead of 2 points, we're told what the slope is and what our coordinate is. Well, I mean, not surprisingly, this is going to speed up this process because we don't have to go through this middle part right here in order to find the slope. We're given half of what we need. We're given the slope, and now we can find what the y-intercept is. So if I were to move in here and grab that, in this case, I know my slope is 6, and I need it to go through the coordinate 325. So that's going to get me a little further away than what my graph default is. So we have this point here, and it needs to have a slope. It needs to have a slope of 6 there. So we know this part right here. We know this is some 6x plus b. We can see that we can catch this now by plugging in 3 in for x, and then we can plug in 25 in for y. And this is something that goes quite a bit faster because we know that 6 times 3 is going to give me 18. In order to solve that, I'm going to have to subtract 18 from both sides. So I'm going to subtract 18 here, and then I'm going to subtract 18 there. On this side, that 25 minus 18 is going to give me 7. And then those 18s will cancel out. That's why I did it. So that way we've got b is 7 there. So if you want a linear equation that is going to have a slope of 6, then you need to have that. And if you wanted to go through this specific coordinate right there, well, then this is going to have to equal 7 in order to catch it. Right? So you can kind of picture this line is going to be maintained through here. See, if I threw a slider on it here, we could have a whole bunch of possible linear equations that have a slope of 6. But there's really only one that's going to make that work, and that would be where this thing is 7. So that's how we figure out our second piece of it. Right? It would have to be some 6x plus 7 in order to get those two pieces to it. I'll do it one more time, and then I'll go ahead and end the video. So our slope is going to be negative 6 for this question, and then it's going to go through the coordinate negative 951, which is even further away. So I'm going to go ahead and catch this part first, so we know that. I'm going to get rid of that, and then I'm going to plug in my point, negative 951. So that's even further away. So here, let me get rid of all this. I'll zoom out just so we can see it. So again, it's got to go through that point, and it has to have a slope, negative 6. It has to have a slope of negative 6. Let me check to make sure. Yep. And it has to go through this coordinate, negative 951. So you can picture it's going to be a decreasing line that's going to be moving down that way. And we know what our slope is, so now we just need to figure out what happens if we want it to go through this point and go for those x and y values respectively. Well, I mean, this shouldn't take us too long here. That negative 6 times negative 9, that'll give us a positive 54. And then in order to get rid of that 54, I'm going to subtract 54 from both sides. And what we're left here is negative 3 equals b. So if I had this, again, I could have a whole range of values for it. Right? So this is with negative 6 as our slope. If we can move along, there's really only one that's going to get us that point, which is going to go through this coordinate right here, and that would be where this is, negative 3. All right, well, I hope this was helpful. Please let me know if there are any more questions in the comments below, and I'd be more than happy to help. Have a good day.